Andreas Stummer, our Director of VMA Sales, VMA Getzman Sales. And the title is Innovations in Production, Dispersing, and Milling. We will talk for about 40 minutes or so, and then we'll have time for questions at the end. If you have any questions in the meantime, feel free to put them in the chat, and we will try to get to them at the end as time allows. We are recording this presentation, so you will get a copy of the presentation afterwards with the recording. And we also always put our recordings on YouTube as well. So with that, I will turn it over to Andy, and we can get started. Thank you.
Thank you, Sherry. Thank you, everybody, for joining us today. Welcome. This is going to be a presentation about milling and dispersing equipment for manufacturing scale. We're going to also have a short introduction just to talk a little bit about the company, VMA, and the relationship with BYK. Here you can see this is basically the booth that we had, VMA, at the European Coating Show. You can see some of the manufacturing machines right here on the right side. These are basket mill attachments that are on these machines. And then obviously BYK-Gardner, known as the trademark owner of the Dispermat brand, and as well as Tourist Mill, which are their basket mills. They make everything from small scale, laboratory scale dispersers and media mills, all the way up through pilot and then manufacturing. So these are just examples. Obviously, there is larger units that are on this picture with bigger vessel sizes, but basically this kind of shows you the breadth of the equipment. So the company VMA Getzman was actually founded in Germany in 1972. This beautiful couple on the top left, top right, Hermann and Elke, are actually the founders. Hermann is 87 and he's still coming into the office once a week just to make sure that they're still following his design philosophy, that modularity approach we'll be talking about, and just that the things are going smoothly. The very first Dispermat was introduced in 1973, down on the bottom, that picture. And that was a lab scale unit. And we actually have customers that are still using original dispersers. The motors are really good quality. We only use brushless step motors. That is true also for our manufacturing motors. So there are no belts or anything like that that need to be replaced. So they are really good quality. And if you've ever worked with a Dispermat, you would know that or recognize that they are really quiet. You can hardly hear them when they're running. And there is hardly any vibration to them. So they run very, very smoothly. So basically, BYK and BYK-Chemie and BYK USA have been using Dispermats throughout all the lab space globally since actually the 70s. And in the early to mid 80s, BYK brought some of these units over to the US, and we have them up in Wallingford, Connecticut. And when customers came in to visit the lab, they were asking if they would be able to acquire a Dispermat. And this is when we started this strategic relationship with VMA to sell their products in North America, US and Canada, as well as Mexico, and basically offer that product line. Back then, we only offered laboratory scale dispersers and pilot units. And about 5 years ago, we started also to offer the whole manufacturing line. There's a lot of interesting innovations and products that we offer that you won't find anywhere else. So the company's still in family hands. The company is run by the two sons, Christian and Martin Getzman. They have over 100 employees. They're a global company. And as I said before, they are known to make really high quality dispersers, different media mills for lab space as well as manufacturing. So here is a picture of the company in Germany. They're about 30 miles east of Cologne, so kind of in the middle of Germany. And one thing that stands out is that 40% of everything that VMA manufactures is custom. So there is a lot of new applications. Just think about battery development, specialty inks, 3D print media. Those applications or end use markets really require a lot of time very custom solutions, and VMA is actually really good at providing some of these options to customers and making custom units. So that's where we're building these units is outside of Cologne. They added that building in the middle 2 years ago. So there's a new design center and more production capability. So we also offer laboratory trials here in the US, up in Wallingford at BYK USA, or in Germany at VMA headquarters. We have also an outstanding applications lab where if you wanted to send in materials or join us for a trial to look at the equipment, we offer those capabilities. And we would welcome if you would join us. Just a brief overview of the dispersion process. Most of you are probably very familiar, but I just always like to just go over it briefly. This is not the in-depth presentation, but just giving a quick overview. So what we're actually trying to do is very simple. When we disperse, all we want to do is we want to break up binding forces. Binding forces, also called Van der Waals forces, are basically these invisible, almost magnetic forces that bind primary particles together. And the idea is to produce enough shear to break up these binding forces, separate these agglomerates and aggregates and turn them back to the primary particle size, and then keep them in a suspended state. That is actually the whole idea of dispersing. And then obviously you want to stabilize these particles to keep them in a suspended state so they don't flocculate back together. So this slide shows really well how we approach this. Breaking up of the binding forces is first. In the pre-dispersion process, we use a Cowles blade. That allows us to take these larger clusters, these agglomerates, break those up, the binding forces, turn them into aggregates. And then once we reach about 10 to 30 microns of particle size is when we would start the media milling process. That's when we use either a horizontal bead mill, a sand mill. We could use a basket mill. Some people like to use 3-roll mills. But that's when we really go from the aggregate level down to the primary particle size level. And that's what happens when we are actually milling. When we're dispersing, we are only basically de-agglomerating, and we are not going down to the primary particle size because just using a blade is not giving us enough shear force that we would be getting with the actual mill head or rotor in a horizontal media mill with the beads to give us these extra shear forces needed to really break up these aggregates and turn them back into primary particle size. And then you can see that picture on the right where we use the additives. They're very important then to keep these particles in the suspended state and so they don't flocculate back together. Just a quick slide showing you different types of pigments, what that looks like on an electron microscope. Pretty cool. And here it kind of shows you the breakout. At what point we want to stop dispersing with the Cowles blade and start the milling process. So again, the real threshold is about 10 microns. We say between 10 to 30 microns, depending on the formulation, on the product that we're trying to disperse, is really when we reach the point of when we need to do the milling. With the right media milling setup, we can really go down super small, and we have applications where we actually below 100 nanometers of primary particle size. It will take quite a while to get there, but this is really something that can be achieved with the right setup, the right beads, the right media milling system, and that should be no problem at all to be able to mill that small. So what we offer is basically, again, the dispersion process is there's two parts. So with the pre-dispersion, we offer the dissolver range for production. Dispermet SC, we'll look at that. And then for the fine dispersing, that second step, where we are milling or grinding, we look at vertical bead mills, basket mills, as well as horizontal bead mills. And there we have also quite a nice range of different materials. One thing that's important is when you're pre-dispersing, that's a little bit of theory. The pre-dispersing tip speed should be between 18 to 25 meters per second. And when you're milling or grinding, our rotor or milling disc speed, peripheral speed, is slower, and it's about 10 to 16 meters per second. So we don't need as much speed as we do when we pre-disperse. But that's some of the theory behind the actual milling process. So here are just some of the different end-use markets where our equipment is sold into. This is not, it doesn't include all the new end-use markets that we find out every day, but this is just a snapshot of the areas where our equipment is used in. So obviously, coatings, different types of pigment. We are born out of the pigment world. Various additives, inks is big one. Different types of chemicals, additives, plastics. Also in the construction, chemistry, electronics, adhesives. We have vacuum systems that are used for adhesives applications with wall scraping units. Different types of pharmaceutical applications. Cosmetics is a very big one. Agrochemicals, lithium ion, and then also 3D print and new type of technologies, these electrosizers with special requirements for their inks for hydrogen applications is another one that's not shown here that I can think of where that equipment is used. So here's just a picture of a manufacturing facility that actually is using different Dispermats for their efforts. So basically one thing, what I mentioned earlier was that modularity. That is a key feature of the Dispermat line, is that you are able to disperse and mill with the same machine. So you do not have to buy different machines. So basically, if you look at that picture, the model right here in the center has a cowl's blade attached for your pre-dispersing efforts. And then the same machine basically right next to it would basically have a basket mill attachment. They just have multiple machines, but basically it's the same machine, and you can switch from basket milling to dispersing all on one piece of equipment. So here is the Dispermat SC. We can go up to about 2,000 liters of product volume. So a 2,500 liter tank. We have built larger systems on a custom basis. Various control panel options. We offer this quick change system where you can go seamlessly from the dissolver to the basket mill or rotor stator. All optional. And then basically we have that vacuum upgrade. The advantage there is that it basically allows you to remove air and have faster product transfer, so no bubbles. And then a pneumatic lift cover to pretty much lift up the cover independently from the shaft, so you can go up higher, so you have better access to clean the bottom of the container cover. And then for various applications, really thick materials or very thick zootropic materials, We offer an optional wall scraper, and then we also offer explosion-proof options if you're running solvents or it's required by your safety team. We also have smaller SCs, or larger units. So depending on your size requirements, we can support you with all the different models. But they will go from about 35 liters, which is around 10 gallons, all the way up to 2,000 liters of material. So here is an example of the quick change system that I was talking about. So basically, you start out dispersing, and when you are done dispersing, you just remove the shaft with the dispersing blade, and then you just pop on the basket mill, tourist mill as we call it, onto the same machine. The changeover will take about 5 minutes, and then you're able to do milling all on the same machine. Now, milling is a very abrasive process, as you know, so we also offer ceramic options in our basket mill, so you don't have any bleed-in from the stainless steel of the standard of the milling chamber, because in the standard version, it's all 3/16 grade stainless steel. But if you're milling a lot of white or light materials, you will have bleed-in of the steel into your slurry, and that could turn a beautiful bright white into a dull gray. So with extended milling time. So therefore, for some applications, we're dealing with these type of colors. It's recommended zirconium oxide or silicon carbide as an alternative to the stainless steel layout of the basket mill. We also can, as I mentioned earlier, add a rotor stator. So there is a number of customers now that are actually grinding down their pigment with the use of a rotor stator, or homogenizer, as some people call it. It's also effective, but I will caution you, it doesn't work well on all pigment types or for all applications. If you are dealing with a really viscous slurry, then a rotor stator is not very suitable, because it's very difficult for the product to flow into the rotor stator and come out. So it's basically just sitting in the middle, spinning, and the product won't properly flow through the openings of the rotor stator. So it's only good for certain products, but we can always do a trial at our lab in Wallingford. We have a rotor stator, and evaluate and compare it to a basket mill and show you the data. Okay, so here is an example of the SC with a vacuum configuration. Again, this could be important if you want to remove the air of your slurry. Again, some customers are running or dispersing like adhesives type materials, or in battery manufacturing for some of these electrolytes, they cannot have, or they like to remove air also, or for some ink applications. So here is an option to get the special container and vacuum cover, and then have the ability to remove it. There's also the option of adding different ports. For example, some customers like to add a nitrogen blanket or disperse in a dry environment. So by creating a nitrogen blanket, you're able to do that. And then basically another big advantage of running with the vacuum system is the elimination of foam. You'll be able to put in more energy, because if you think about air bubbles, they act almost as tiny little air mattresses, and they will buffer the blow of the beads if you're milling. And therefore, removing that, you have higher efficiency and more energy input into your mill base, which should yield better milling or quicker milling results, and improved wetting and better dispersing effect by running with the vacuum system. It is not cheap, and it requires a really a different stand configuration, because the cover is pretty heavy, because it has to support all the pressure ratings that you'll encounter when you're dealing with vacuum. Here's a close-up of a pilot unit with the vacuum system. So you have different product entry ports. You have also viewing glasses, so you can actually see what is happening during the dispersing or milling process. You also have an internal light that you can turn on, release valves for the pressure, and purging ports for nitrogen or argon gas, depending on how you want to run it. So then we offer different control options. So on the right side, you can see this is just a standard manufacturing type control panel. Very easy to operate for the operator. Just buttons and a few lights, and you can see all the critical information on the display. And on the left side, you can see the new C technology control panel, which is basically is born out of the R&D lab space. And then some customers want to have the exact same control panel in manufacturing and processing. So you'll be able to basically look at a lot more data. You can look at the actual milling or dispersing diagram. So you would see each of these values in a trend line during the dispersing process. So your speed, the energy input in watts, you see actually a reading, a torque reading, which is an indirect measurement of your viscosity. So you can monitor how it's changing. It'll give you actually the tip speed, which is the peripheral speed of your blade or milling disc, or temperature readout, and a timer function right on the screen. Now you can also store batches by name or by product ID or date. And then next time when you want to run the exact same product, it uses exactly the same parameter, even to the point where you can set the impeller blade height in the container exactly the same every single time. You can also set up what's called an oscillation mode if you want the blade to go up and down. Or you can program what's called cutoff values. Let's say you want the machine to power off after, let's say, 2 hours of milling, or run with a different speed or different energy input. Then this control panel gives you all these options. It has limit switches for temperature. If, let's say, you have a temperature sensitive product and you don't want to reach, let's say, 100 C, then you can program it so that it gives you a warning, let's say at 80 C and at 90 C, and then at 100 C it'll power off or run with a different speed or different energy input. So multiple ways of how you can configure it. Personally, I think most customers would prefer the option on the right because it's pretty simple and easy to use. Also for manufacturing, for an operator, it usually is not the cleanest environment in a manufacturing room. So that panel on the left sometimes gets dirty quicker. And then with these buttons, I just think that the panel on the right is a little bit more easier to use for most operators. And then we also have the option of a programmable panel, and that is supplied by Siemens. Some people actually, for manufacturing purposes, like to integrate a scale. So the actual Dispermat sits on a scale on the ground, and then you can just add the raw materials without having to move the container around. And that way you can see all the data on the screen right here, or other manufacturing processes can be integrated here. For example, removing off the mill base, pumping it out to a different container. So this is a control panel that can cover a lot of your quality control applications in the manufacturing world. The lead time right now, unfortunately, is about a year on that control panel. So they have a huge backlog, but it is available if your maintenance or operation team requires it. This is just an example of the pilot plant we have in Germany. So we have different types of machines. We actually have additional equipment now. So this is only a snapshot of what we have. So we can also do larger scale trials to evaluate the performance and that you can see it's working well with your product. Then a really interesting solution is that Dispermat TM. TM is a 2-in-1 combination system already integrating the dissolver and the basket mill. So you do not have to make any changeover. Even though you can change it relatively quickly on the SC that I showed you earlier, which is about 5 minutes to change from the dissolver to the basket mill, here you don't have to change it. It already is integrated. So basically you have your mill base, you putting the container under the dissolver, then you push a button on the control panel, you are pre-dispersing with the blade, you can add more materials, then you are doing your pre-dispersing time. When you are ready to do milling, you push a button on the control panel, and then the basket gets lowered, and now you're doing your milling. And then after a certain time, when the milling process is completed, you lift it up, and then here is your finished material. So everything on one location, on one machine, very, very seamless and very nice. So that allows basically a customer to buy one machine instead of multiple machines and save space because all your work can be done in one location. So with the TM, because the basket weighs quite a bit, we have a little bit lower volumes. So the product volume is going down from 2,000 to 1,600 liters. Different control options as we discussed. We also have an explosion-proof model, ceramic options for the basket. We also offer vacuum capability as well. So here kind of shows you just how the basket comes up and down. Very good also if you already have a basket mill in our labs, in your lab space from VMA at Dispermat. It's very scalable, so you have really good upscale results from the lab to the manufacturing process, Dispermat. The baskets are double walled, so it's very important that we have the ability to control the temperature and basically keep it as cool as possible. So we have very good cooling in our basket. The basket itself is double walled, and then we basically on the bottom of the basket we have a screen where we actually allow for the product to flow out. There's a cowl plate below, and then I'll basically pump the product back to the top. And then there is a pumping wheel inside that basically sucks the mill base back in. So you have really good circulation in and out of your basket mill when you're milling materials. This is an example of 2 TMs at a customer somewhere in the Midwest. So they basically use them 24/7. What you can see here in the picture is a 2,500 liter container. In the backside, the gentleman with the gray sweater right behind him, leaning against the blue drum, is actually the dispersing blade that is not installed yet. So you can see right above it is the basket, and then you would have the dispersing blade right below. And then the model on the right side is exactly the same model, except it's collapsed. And that's what it would look like during the actual manufacturing process. And then we also offer the Dispermat, the Tourist Mill SK, which is exactly the same thing as the SC, except the SC ships as a dissolver, and then you convert it to a basket mill. Here we ship a basket mill, and then you can convert it into dissolver. So basically, it's just the same machine, but one ships like a dissolver and one ships like a basket mill. But you can add that quick change system and convert that also into a dissolver if you want. Again, here 1,600 liters when you're milling, explosion proof available, that quick change capability, ceramic option. We offer a nano kit for our basket mills, so it allows you to use super fine beads down to 0.2 millimeter. And then also a vacuum option is available. And then quick color changes. So the advantage of having the removable basket is that if you run multiple color families, you can just swap out the baskets and basically don't tie the machine down for extended periods of cleaning, because you can just swap out the basket and move on to your next color very rapidly. So that's one of the big advantages of that modularity approach. And the way that this quick change happens is we have these trolleys, and then you just push it underneath the machine, and then you basically swap it out. There's a clamping ring on top, and the quick change system basically allows you just to turn the shaft a few degrees, and then it'll come down, and it'll basically sit right on the trolley, and then you remove it and put the basket mill there or the dissolvent wherever you are in the process, and then you'll change it that way. It's really easy to do, and it'll take less than 5 minutes. So it's pretty sweet. And again, for different color families, customers just buy multiple baskets, and some customers have 3, 4, 5, or even 10 baskets that they utilize when they run different colors. So here's just a drawing of the different stages when you're using the SK. Just go there with the container, pre-dispersed material, lower the mill, and then just mill, and then remove the container. So this is kind of the design of the basket mill. So you can see inside of the basket, we have our pumping wheel on top, and then we also have our milling disc right around the milling disc and below our beads. And then we do not have a screen on the side of our basket mill, because this is where we're actually cooling. Most of our energy that we are putting into the process is actually created right here around the milling disc, and basically that's where the beads get thrown around at high velocities inside of our basket, and that's where you will see most of your energy build up, and that means increase in heat. So you want to really cool that portion of the basket mill properly. Therefore, we designed it so that the screen was on the bottom, and then right below the screen we have the cowls blade to actually remove and draw the mill base out of the basket and then push it back to the top, where then that vortex or pumping wheel will suck it back into the basket for a really good rotation or movement of your mill base in and out of the basket. So you get a lot of good circulation movement and also very good cooling. If the screen was on the side of our basket, that means much higher wear of the screen, because this is where your beads get thrown towards. And then we have seen like some competitive mills with the screens on the side, there's a lot more wear on that equipment than on that design right here. So this is actually what the manufacturing size basket mill looks like. So you have the screw right there, you remove it to actually add beads. And then right below, you can see the cowls blade right there. And then this portion, all of it is basically double walled, even the top. And that's where we have our effective cooling. So the cooling comes in through these bars right here. So we have one bar cooling in, or water in, and then cooling the water out. And then on the back side, there's a third bar that actually has our temperature sensor. So here we can accurately measure the temperature inside of the basket. That gives us a very, very accurate reading. So then we also offer manufacturing scale horizontal media mills. So that is the RS. It comes also with different configurations depending on how much product you want to make. Of course, some of the key advantages of a horizontal mill are I'm able to go down to super small particle size, like below 100 nanometers. I'm able to use different viscosities, even really thick viscosities that I wouldn't be able to use on a basket mill. I can use a horizontal mill with a plunger setup. So I'm actually forcing my mill base through the mill. I have also the ability to use ceramic and nano kit. I have a vacuum option also to remove air. Um, Again, different volumes per hour depending on the size of the model, uh, all the way from 25 liters to 250 on the RS5, and on the RS30 we can do up to 1,000 liters per hour, which is really fast. And we also make bigger systems on a custom basis as well. Of course, the disadvantage of a horizontal mill is the maintenance and the cleanup. So it takes a lot longer to clean than a standard basket mill, for example, um, just because there is more parts and the milling chamber and the rotor, removing the beads is kind of cumbersome. It's a lot easier to do that on the basket mill. And then you don't have any lip seal or O-rings or seals of any nature on a basket mill. You really have them here, and then periodically you have to replace those. Then you have to make sure that they're chemically resistant. If you're running special solvents that may attack a standard O-ring, then you have to purchase different types of O-rings. So it becomes a lot more complicated to maintain and run a horizontal mill rather than a basket mill. So we have a lot of customers that are moving away from the horizontal mills over to the basket mills if their viscosities allows them and volume allows them to do it. One advantage I have with the horizontal mills is obviously I can do this the pass through. So I'm not limited to a container size, where on a basket mill it's all basically a batch system. And here we are not dealing with that. We basically can do pass through, or we can do recirculation mode if we have to mill for an extended period of time. If some people like pass through and they don't go through the mill a second time, so then they would just have multiple mills set up in succession, and then basically they run from one milling chamber to the next milling chamber to the next milling chamber. And that way they can just do a continuous mode and produce a lot of product very quickly. This is for large scale manufacturing facilities. We have setups like this. Then we have what's called an APS system. And I say production with the caveat, it's not really large scale production. So this is actually born out of the lab space for very easy milling and quick milling. So basically you have a system with two containers. You have a top container that basically has your media, your mill base, and the milling disc. And then you basically will do your milling in that container. When you're finished with the process, you would remove a drain plug. There's also a screen that separates the mill base with the media from the container below. And then you use an air a purging method to basically hook up an air hose through the socket in the cover, and then you can purge your mill base with air pressure out from the top container into the container below. So that is a very easy way of milling. Now, it's not really designed for large scale manufacturing because it would require a lot of beads in a setup like this, because you can have 100% bead loading ratio to your mill base. So if you have, let's say, in the lab, let's say you have a 1 liter mill base, you can use 1 liters of beads. So imagine if you have 1,000 liters, you would need 1,000 liter of beads. It's very expensive and it doesn't make any sense because cleaning and handling of the beads gets very complicated. So the largest system that we would make is something like, we have custom systems for 25 liters for small scale production. We have a customer who makes platinum pastes for catalytic converter applications, and it's very, very expensive material. So for them, 20 liters, 25 liters is already manufacturing scale. So this is why we put that in here, just to give you that option in case you would be dealing with really expensive materials, and your manufacturing scale might be a lot smaller, what somebody else might consider pilot scale or large lab scale. But that would be that option of the APS system. Big advantage here, it's fantastic for the lab because it's very easy to set up and also very easy to clean, because once I remove my mill base, I just put the drain plug back in place. I fill up my vessel with solvent or cleaning agent with the right polarity, and then I run it for a few minutes, and then I drain it out the same way that I extracted my mill base before. So then I just get rid of my cleaning solution, and then I rinse and repeat until I have a clean vessel and clean beads. So this is really, really simple and very attractive to a lot of people. And the milling performance is really good and very comparable to a horizontal media mill. So you can do very, very small particles, and also it has a very narrow particle size distribution. So this is an excellent milling tool. And then here, just a picture of the lab in Germany at VMA, where we can do a lot of trials and show you also the manufacturing scale equipment in our pilot plant. And then here is our lab in Connecticut. There is more equipment in there that you see here. We actually have a new AE6 with the C module, and we have the SL horizontal media mill also for upscale trials. So we actually have two AE6s, and we also have a small CB3. So we have a really nice lab. There's a video. We have a YouTube channel, and there is also a video on there of our lab, and you can do a tour. And if you want to visit us up there, please let us know, and we'll be welcome. We'll be more than welcome to come up to look at the equipment and maybe do a trial with your product. So that's that site in Wallingford. We have sometimes customers that just look at the equipment, or we have customers that send people in for training. They need to learn more about the milling process. We can set that up for you. Also, scale up and calculations for lab scale to manufacturing. We have that capability. But what's really good is that we have a good synergy with BYK USA, and we work with our chemists one-on-one, and they will actually help us improve formulations if that's something that's required, or if you want to look at alternative additives or get some ideas on what that would look like from a processing standpoint or upskilling standpoint. So we have all this capability. So we don't want to just come across as somebody selling you a piece of equipment. We want to really be a partner to a larger solution and help you make the best possible product the most efficient way, also with the additive team support. Not only us being a standard equipment manufacturer or reseller. So that's what we can offer, and thank you very much for joining us today. I hope this gave you a pretty good idea of what we can bring to the table, and I'm opening it up for questions.
That was a very in-depth presentation and good explanations of things as always. If anybody has any questions, if you could just put them in the chat, I'd be happy to answer them. I see someone is typing. I'll just also say that Jonathan Bain, he is one of our sales reps that has joined Andy's team. He's been with the company for quite some time, so he's knowledgeable with the dispersion equipment, but he will be focusing on that. So you may hear from him from time to time, or a lot of time, maybe.
I see Ramanan has joined us also. Welcome, Ramanan.
We do have a question.
Yes.
What bead size do you advise for dispersing nanoparticles like nano TiO2?
So It depends on what part of the milling process we are, but usually, and what the ultimate particle size needs to be. But basically, we can go all the way down to zero point 0.1 media. But you can't start there, obviously. You start larger and then you work your way down. But that would require the use of a horizontal media mill. We cannot do that with the basket mill, unfortunately. The threshold there is about 500 nanometers, kind of the limit with the basket mill. So for a very small particle size, we need to use the horizontal media mill. But with the nano kit or the nano configuration, we have the ability to use that super small beads. And you can come to Wallingford, Connecticut, and take part in a trial. We more than welcome you to come up.
I hope that answered your question sufficiently. Does anybody else have any other questions at this time?
You can reach out directly to me. Maybe Sherry, you want to put my email in the chat? I don't know how to do that here.
I can do it.
And can email me directly. If you're interested in visiting our lab, please let me know. We can set that up. The only thing we would ask is that we would we would send you a form to fill out. It's called the incoming raw materials form. And that basically lets us know what you would be sending in. And then the SDS sheets with that form for the materials. And then we'll have that reviewed by our EHS team. And then basically we can set up a time for you to come in and look at the equipment and run your material.
And you can most certainly, any of the emails that you receive from us, if you reply to any of those, either myself or someone from the marketing team can certainly get you in touch with Andy as well.
So, absolutely. And this presentation will be online, so Sherry will upload that. And then do we have a link for the YouTube channel that we can post?
Grab that as well, yes.
Some critical points when dispersing nanopigments, obviously, time. It's going to take quite a while to get down the particle size, break up the binding forces. Critical there is absolutely must have ceramic configuration when you're dealing with nano, not stainless. It's going to be a requirement. We also need very good cooling. We are putting in a lot of energy. So cooling is really critical for an extended period of time. And then obviously always be careful that you use the right dispersion. So we would definitely tie in our colleagues at BIG, depending on your formula and the type of application, to use the specific additive when we're dispersing nanoparticles. And these are some of the key points that I would look out for. And then do constant measurements, because you also don't want to overmill the material. So we have a particle size analyzer. We want to look at that and see how we are progressing. I mean, you should be able to see it on the torque curve or the energy input, because as you're milling, you would be increasing surface area, and ideally you should see an increase in energy input. But keep an eye on that. Temperature is important, and then obviously the right choice of additive, definitely. So I hope that answered your question, Joachim. One other point I want to make about that is the choice of beads. Obviously, we didn't talk about that today, but we only recommend zirconium oxide beads, ceramic beads, either cerium or yttrium stabilized. They're much harder than glass. So if you were, for any milling application, but specifically for nano applications, you absolutely have to use high quality beads. this is not a time to save money. Okay.
Are there any other questions that anybody would like to put into the chat at this time? We also have on November 7th, we'll be taking a deep dive into dispersion, as well as November 16th, media milling deep dive. If you haven't already seen invitations to those, you should be getting those, or you can refer to a previous registration. We also have color and appearance webinars and office hours that we'll be doing, a couple more here at the end of the year as well, if you're interested in any of those.
You know, and obviously, the right choice of milling equipment is always about saving cost and saving money, and time is important. So think about cleaning, you know, when you make these decisions. I mean, I had a customer in the lab not too long ago. We were really blown away. It was for an ink application, and they were doing 3-roll milling for the last 50 years. And basically, they hired a new chemist, and they said, while we're doing it, we should be looking at basket milling. So they came up to the lab, and we had 3 different inks. We had a blue, a green, they were UV curable inks, and a yellow. And basically, what would take them 18 hours on a 3-roll mill, it was done in 45 minutes on with the basket mill. It took maybe 2 weeks, and we got a phone call back from them, and they were going ready to place an order for a basket mill manufacturing system. So imagine had they done that 30 years ago, how much money they would have saved moving away from that old process to something a little bit more up to date. Sure, it's an investment, but it basically will pay for itself if you make the investment at the right time and for the right reasons. And if, of course, you get the performance of the equipment, that's number one. But you know, the first step is come to the lab, visit us, and come in for a trial and look at the equipment. And then we can make evaluations together and then decide what would be the best path forward if you need to make some adjustments to your manufacturing scale. Or even lab scale, you know, we have many options, or pilot, you know. So we have presentations geared towards lab scale also. So. So again, thank you very much. If there are no other questions, just email me or, you know, reach out to Sherry and let us know how we can help you.
Thank you. Thank you again, Andy. And thank you everybody for your time. And we'll give you a couple minutes back in your day. And we look forward to chatting with you and having you at more webinars. Thank you.
Thanks, everyone. Have a good one. Thanks, Sherry, for setting it up.